This video is about motion and kinematics, which deal with the motion of an object as it's moving. First, we'll deal with simpler one-dimensional scenarios, like dropping a ball. This is a one-dimensional scenario because the ball is moving in a straight line. So in a scenario like this, we might want to know how long it takes for the ball to hit the ground after it's been dropped, or how fast the ball is moving right before it hits the ground. And then we'll deal with more complicated two-dimensional scenarios like this baseball player throwing a ball, where we might want to know how far the ball goes by the time it hits the ground. The basic technique to analyze the motion of an object is to throw some variables into a set of equations, which are called the kinematic equations. The variables are displacement and distance, velocity and speed, acceleration and time. Before we look at the kinematic equations and throw these variables into those equations to actually solve some problems, we need to discuss these variables in detail and make sure they have clear mathematical definitions so that we can apply them in the equations. Let's start with displacement and distance. To describe what they mean, I'll use a one-dimensional example of a ball rolling horizontally on a floor. Now let's put a coordinate grid on it. So here's the initial position, here's the final position, and the question is, how far did the ball roll? Pretty clearly it rolled 8 meters. We have 3 meters on the left side of the grid, 5 meters on the right side of the grid to give us 8 meters. But we can give a more complete answer. It rolled 8 meters in the positive x direction. So this piece, just the 8 meters, is our word distance. And then the whole thing, the distance and the direction, is displacement. So distance is only a magnitude, there's no direction, and the word displacement is a magnitude and a direction. Just FYI, I want to introduce a couple of words. A scalar is a variable that only includes a magnitude, and a vector is a variable that includes a magnitude and a direction. We're actually going to talk about vectors a lot more in the next chapter, but I just want to go ahead and mention them right now. So let's come up with a mathematical definition of displacement. Just in words, displacement is a change in position. Now we can have a change in position in the x direction or the y direction or the z direction, any of the three directions of three-dimensional space. But specifically for the x direction, we write it this way. Delta x is equal to x final minus x initial. So the xf and xi are final and initial. Notice that delta for us always means final minus initial. It never means initial minus final. So, and that's true in math and other disciplines too. So please always remember it's final minus initial. So that's displacement in the x direction. We can do it in the other directions as well. So in the y direction, it's y final minus y initial, and in the z direction, it's z final minus z initial. So obviously they're pretty much the same. Okay, so now that we have an equation for displacement, let's go ahead and apply that to the rolling ball. So just as a reminder, we said that the displacement was 8 meters in the positive x direction. Let's go ahead and throw the numbers into our equation and see if we get the same answer. So here is our equation. X final is 5 meters. X initial is minus 3 meters. So we have 5 meters minus 3 meters. So that comes out to be 5 plus 3, or positive 8 meters. That is actually the same thing we just said, because this positive here means the positive x direction. So we get the same answer. Just as a little bit more practice, let's roll the ball exactly the other way and see what happens. So this time, here's the initial position and here's the final position. Now we can anticipate what the answer should be. Again, it's going 8 meters, but now it's going in the negative x direction. So 8 meters in the negative x direction is the displacement for the ball. Let's go ahead and plug it into the equation though and see if that's what we get. So here's our equation. X final is -3, x initial is 5, so we have -3 minus 5, so the displacement is -8 meters, or 8 meters in the negative x direction. So we get the same answer. So that's basically it for displacement and distance. Next time we'll talk about velocity and speed, and then we'll go on to acceleration, and finally we'll get the kinematic equations, and we'll put the variables in there and start to solve some actual problems. See you next time.